Hi everyone, my name is Mattias Lugberg, and today we're going to talk about, well, nowadays one of my favorite topic, but when I started my journey in the cloud, this was probably the thing I was running away from, networking. It's gone quite far during this year, so you have been with us for almost these 10 years or something that I've been doing this. You know that in the beginning we didn't even have something called network. It was awesome. But nowadays we need to comply a little bit more with it. Let's just leave it with that. The session today is all about trying to explain what's going on, because we as developer architect often get the requirements to handle network, but we are not always aware of all the complex that goes around. And the idea behind this session is to give you an understanding of both changes during the development, but also understanding more about what's going on and why things are happening. Because in networking comes a lot of things that we don't really understand that well, which is all from DNS to routing to firewalls to everything. We won't go in depth of that, but we will explain where things is going, and hopefully you will have a better troubleshooting situation in the future. And the whole thing today is going to go whiteboarding, because I really love whiteboard. So I'm only have one slide, which is whiteboard. And so let's get started. So this is my favorite tool. And if we're going to start about network, let's just start with the basic stuff we know. So we have this on-prem stuff. Let's just draw a little house over here, just to make it a little bit nice and sweet. And there we go. Look at my little house. Hope you feel welcome. Let's put the door up there. So this is our on-prem. This is where we come from, and we usually need some sort of access there. So let's just look at how that can be done, or usually is done, more or less. So in Azure then, we create some VNets, that's called. The first one we're going to create, which is, if we do the hub and spoke, this would be the hub. Or you probably do hub and spoke, and we will talk about hub and spoke in this case. So hub and spoke is a pattern for networking, and it's all about having one hub and a lot of spokes that you use later. So the hub, which is the first and most important one, is the one we're going to draw now. So let's just do that, and let's draw it up. And when I talk to people, because I learn this by talking to people, they usually create this first one with at least 3 subnets, or the ones I'm talking to do that. So I'm going to do the same. So let's do 3 subnets. These 3 subnets have very different usage. So the first one, or the one to the right, that's going to be the gateway. So in this, we're going to place a gateway. This is the one we're going to connect down to our on-premise. You usually talk about this as an express route. This could obviously be other ways as well, but let's just take an express route. Let's use that. So this is the initial connection between on-premise and cloud in this case. And in the next one, we're going to have our big old friend, the firewall. So this is the firewall, and that's going to be a very central piece, as you know, in network. But there's also a few other components that is created as well. Something called a route table and a network security group. So network security is going to be shortened NSG, and route table is going to be shortened route table. We'll talk a little bit more about this in the future, but they always comes up on every subnet in the end. So we will have a, let's see, there were really small writing on that. Let's see if we do a little bit bigger route table. Wow. Okay. Let's do something for future for colors for this. Let's have a color. Let's do this yellow, and let's add a blue. NSG. So we have the blue one over here, and we have the yellow one over here. So let's do it like that, make it easier to see. So this is the kind of starting point. Next up is another one that we usually need. So now we're going to create our first spoke. But this is also necessary for us because we're going to create DNS place. So we need to have some sort of DNS management. And that's going to be created in another subnet, or a VNet first, and then another subnet. This is usually placed centralized in some way. And let's just do a 1, and let's do 3 here as well. We do a peering over here, which means that we connect our networks. So this is how the hub and spoke works. They pairs networks together. In this first subnet, I'm going to put in a private resolver. So a private resolver is a DNS resolver, in Azure, which then can be used very simple. The good thing about this is that it has one incoming for all endpoint for everything inside. Then we can route outbound, but by default, it will go directly to Azure DNS. And that has some good things with it. Oh, and let's just respell that one. It wasn't really pretty. Azure DNS. So this is the baseline for having a network up there. So we have, obviously, we have this route tables here as well, and we also have the NSGs. You could reuse the same, but I got a recommendation that you should do one for each network or subnet in this case. But, or not but, now we have the setup to get started. Now we want to start doing things. So usually, if you have ever heard of, I'm gonna use the concept landing zone. So landing zone is a concept of giving a development team similar an area to work with. It's usually a subscription with some subnets paired to our firewalls and stuff, or the hub in this case. Let's just write hub in here. Let's just write hub over here. So let's just do that. Let's create this. And we will do as before. We create this by 3, just to make it easier. And let's just do a 1 and a 2. And we do this peering again. Now we can start working with this. We can actually start routing traffic. But there are some things that we need to make sure when this is done, or we don't really make sure about it, but we actually make sure of it from network team usually does. Because it's creating these route tables and it's actually updating the route tables up here. So these route tables are updated when you add a landing zone. Oh, let's go back. There we go. Let's not have that there. Which means that it will get a route going down to this peering. So it actually will be a route from the gateway to the new landing zone. But network team will obviously, they want every traffic to go to firewall, so they will usually go ahead and in this route table, let's go ahead, they will do so landing zone 1, let's go landing zone 1 to firewall. So they will put up a rule in this route table that traffic has to go there. So when traffic comes from on-prem, it's going to go into this firewall. And if you're lucky and you get access, oh, hang on. So firewall is going to go there, and then if you're lucky, you're going to be able to go there. But that's the first thing that they do. They actually do this manual, but scripted, obviously, that they create this route. Same goes from landing zone back in. So the route table that is created over here also need an update, which means that 0.0.0/0 goes to the firewall. But it also needs to have that any traffic going to the hubnet also goes to the firewall. So there are rules they're doing because they want the traffic to go over there. They don't want you to be able to go over here without going through the firewall. So that's stuff that's going on. So let's just write up those NSGs and those route tables. So again, the route table in these are pointing anything going to 000, which is the default route, going to the firewall, or if you go to a specific thing in the hubnet, meaning the gateway, then you go to the firewall first. So all of these will have that. So all of these will have this in this landing zone 1. There we go. But we usually want to add some other stuff to this. We want to start developing things. That's what we want to do. So let's just say that we want to add some services to work with on this. So I'm going to add a, let's use screen, sounds good, a Cosmos DB, a database. It could be a Cosmos DB, it could be a SQL, doesn't really matter. I want to add a Cosmos DB to my landing zone, to my network, and I want it to be protected by our network. We then have two options. We have something called a service endpoint, and we have something called a private endpoint. For you who has been doing this for a while, you know that service endpoint has been there for quite some time, and that the private endpoints is fairly new. And there's big differences, or it's a bit, there are some major differences that we need to be aware of when picking these, because both of them will do protection, it will be granting access and so forth, but there will be a big difference in how they're doing this. So let's just say that we do a service endpoint for our Cosmos DB. So let's just use the service endpoints over here. This will then imply a few things. This network that we're talking about over here, this network will then be configured to be able to connect to Cosmos DB. So it will be a configuration on the subnet that is able to connect your Cosmos. You can then connect one or many Cosmos DBs in this case. Or let's just use another color. Let's use blue. So we can then connect this to this network, but we can collect many. So if there's more of these, we can use the same kind of configuration and do the same connection again, as long as they are Cosmos DBs. So this is a one-to-many. You can connect as many as you want, or not as many as you want. You will obviously have restrictions in IP numbers and so forth. But you can create a lot of them at least. We won't do that. We will keep it to that. Another thing is that when you do this, like I've done now, I've connected the Cosmos DB there. It will be initially open, or accessible rather. It will be initially be accessible to others. But you can, when you connect it, it will explicitly say, hey, you need to be in this network, or you can actually do a list of IPs that is allow list for IPs. So I can actually have my IP allow list over here, which I can add. So let's say I'm a developer, I want to get access from home. I can do this simple by just doing my IP on this allow list. I will have the same access as someone inside of the network in the landing zone, for instance. That's one problem, that you easily can open it up for anyone else. The other one is that it's still publicly accessible. So a big thing about this is that whenever you create something in Azure, you will have a public IP. You will have a DNS inside of your Azure up here. So it will actually get a DNS record here in Azure DNS. And it will have a public IP, which makes it discoverable. So this will always be discoverable during this approach. So service endpoints will always be discoverable. So we can write it over here, discoverable DNS public IP. And we also have this allow list. But the private endpoint works a bit different. We will go through it very soon. But that's how the service endpoint works. And as I said, we can add a bunch more in this as well. But let's do what we're here to do. We want to develop something, right? We want to develop a process. So we will actually want to create a logic app standard in order to connect to this service. So we will create a logic app standard. And as you all know, they are relying on the app service part, which means that we can connect it to a backbone VNet. So we can do this outbound VNet connection, which means that we can connect our logic app back in. In this case, we can then go ahead and build a connector and do this get. Let's just build a small flow, and we have a get data. And we do something with the data, and processes are further on. When we hit this get data point, we will then route our, could be on the internet obviously, but let's just imagine it's going through a network. It will go like this. We'll go up here and it will be, oh, okay, I need my DNS record. Okay, it's over here because it's in the Azure DNS, because this is the one we're connecting to. Traffic, on the other hand, traffic will go this way and securely go back to your service without going anything public. It will be secure, but the DNS part will go, could even be going like this. Zip. Okay, it's over here, and then traffic goes there. It's not very, very like dangerous, but it's something to be aware of. Our logic app usually needs some sort of storage to be able to work, which means that in the beginning of this, we can just go ahead and connect to our storage like this, but we want to lock things down, right? So let's then introduce our, let's bring the arrow back because we can use it. So let's then use the private endpoint. So the private endpoint works a bit different. The private endpoint is something that you can put in a network like this. We'll put it in this subnet. And we'll then open a funnel into this storage. For storage account, we actually need 4 of them, because as you might be aware of, there are different services on a storage account. We got blob, we got file, we got tables and queues that is needed by Logic App standard. So we need 4 of them. We can now get them to access through this network, which means that resources that are running inside of it, they can access it. But they can do that because we have a, let's just do again, a private DNS. So this is the other part of it. So we can create it in this subnet over here. We can connect it, but we also need to have an address for it, an IP. So we will create these private DNS for all of them. And we need one for each type. So for, let's go ahead and just write this down as well. So for storage accounts, we actually need 4 private DNS zones as well. And the beauty when connecting, when we use a private resolver like this, and that has been connected as the DNS zone in our network, is that when we are running this, oh, we can do one more thing. Ooh, let's do the one more. Before we do that, we also want to make sure that we don't get an access like this. We want to remove that access. We can then say public access denied, disabled. And we actually lock down our storage account, and it's not possible to find it publicly. This gets away. So it's not possible to find. So if you would do a NSLOOKUP or something on the same storage account that you to public accessible, set it to disable, you will not be able to find it. The Cosmos DB you can still find, but the storage account is not being able to be found because it's using the private endpoint. So big thing is that it's not discoverable. And it can be, it uses a private DNS. Another good thing is that we can use this VNet or subnet to a lot of these different services. So that's also good. So now, if we go ahead and just look how the DNS settings will go, from the Logic app, when we want to access this storage now, it's not public available. So it will go like this, go to this, and it will go into the private DNS. You get that data, and then you get the IP, and then it will go this secure way down to the storage. So this is a secure, nice way to get into the storage account. We can then, obviously, go ahead and do the same thing for the Logic app, because we might not want that open as well. Which means that we can also, on this end, put it down like this. Obviously, we need to have a new private DNS over here. Let's just draw it like this to be able to put in the DNS for this LogicApp standard. We now have a full lockdown situation, which means that we can't really go to the LogicApp, we can't really go to the storage. We can detect the customers, we can actually open the IPs to it. We could develop from it locally. So if we would do some code or testing locally, we could do that actually. But we can't really go to the LogicApp, we can't go to the storage. So here comes the next problem, deployment. Because if you had done this with DevOps previously, they would have been doing that easily. If you could use the built-in agent, it will just run. But from this point, that we put public access disabled and we use a private endpoint, we can't do that. We are locked out. That also means you as a developer, if you were working down here and you have your nice fancy computer, you will now need to go to a VPN like this in order to get in and be able to connect to your LogicApp. Previously, you could have done that in the open, but from now you need to do that. You need to have a VPN, and then you will go all the way down here. Then you can access stuff. And same goes for DevOps. So we then need to add something that we usually encounter. We encounter let's just write DevOps. So this DevOps has been really nice doing that. But in order to do this, and now I know that I'm not the best on this, but the things I've been working with has been scale sets. What's usually used is that someone is creating a scale set and connect an agent to that scale set. And when we have done that, we can then, through the firewall, allow traffic down to our LogicApp. So we can then, with the agents running inside of this network, that's important, and having this firewall connected and opened all the way down there to this private endpoint, then we can do deployment again. Just as we can connect to it via VPN and on-prem, or if you have that desktop connect VM in the network as well, that could also work. But you need to have something like that in order to get in. But that's an important thing to have coming up. And if we want to also add something like, getting data in, maybe we want that LogicApp to be accessible to some other endpoints, we probably want to add something more. We probably want to add like an API management instance. So we then need to, again, add some subnet. Let's zoom in again so we don't get the big difference in size. So up here again, we then can create a new subnet or a VNet. And again, this is a new landing zone. Let's just do that. All of this is usually a new landing zone. Just to be clear, APM. And let's again divide this in a few because we need a few of these. And let's do this peering. And the funny thing is here, all of these need to be routed through firewall. That's actually something they need to do when they put it up. As I said, it's scripted, so it's no big deal, but it's there. If we work for a big customer, we usually have APM in an internal mode. And if we deploy it like this inside of this subnet, we will then probably use an app gateway in front of this to be compliant with firewalls and then OWASP and that kind of stuff. And then we allow our traffic coming in this way. And then the app gateway can connect to our APM, and then our APM can connect, if it's allowed, through the firewall, down here, through the firewall, down to this again. Same path as the other one, but going into your private endpoint and being able to expose an API to someone. And again, we can use key vaults and stuff. Usually we probably need like a key vault. And let's go. And we probably need like a private endpoint down here to get access keys. And we want to disable it again. And it will create yet another private DNS over here. Again, we'll create a bunch of stuff. But now we can route the traffic all the way to where we want it to be. The interesting part about this is, there's a lot of interesting part, but we need to configure this and we need to make sure. So usually my encounter at least is both when you set this up for an APM instance, for instance, you need to make sure the traffic goes the right way, going down to your app gateway, going to your APM, and APM has a bunch of rules. Just be aware of that. Here's a bunch of NSG rules. We didn't go very far into the NSG, so let's do that now. Let's just add the NSG to this network, and then just add the route table as well, just for the sake of it. And go ahead. So in our NSG, we then need to allow a bunch of traffic. So we can do this. So the NSG is like a mini firewall. It will actually determine what can be accessed inside of this subnet. So in this subnet, which APM is in this case, we can then decide how traffic are allowed. So APM, for instance, is a POS service, which we need a bunch of these. So there is, as you can read up on it, there's a bunch of rules that is allowed. It needs to access SQL, it's storage, it's Key Vault, and a bunch of other services that you can use with a service tag. So you should use a service tag for these. As I said, this is well documented, so you don't need to remember this. Just look at their page or documentation when they do this, but that's something they can do. The NSG allows traffic in and out from it. And NSG can be very protective. So if you would say from the beginning that, let's say in this particular route over here, you can say at NSG, you can say deny all. Deny all. If you do that, nothing can connect to anything inside of the VNet or a subnet. So if we would add that into this subnet, nothing could connect to anything else. So they are very powerful, and they're usually very restrictive in the beginning. So you really need to keep in mind of the NSGs and what rules they are. Most, I would say, have a rather okay approach. Usually not going to internet. Usually traffic needs to go through firewall, and so some services are easy to use. But as I said, APM requires a bunch of special NSG rules, just so you know. The last thing that I want to add in this case, since I have just a little bit time more, is the only thing we didn't really do, and I want just to poke it a little bit. So let's just say we have App Insights for insights. So if you have a customer, or you're a customer that is really keen on security, you can actually lock down your App Insights as well. You can go ahead and say the whole monitor thing. It's called AMPLS. AMPLS. So you can require private endpoints on your App Insights, which means that traffic usually goes like this when it comes to Logic App going to an Application Insight. But if we use AMPLS, and it's usually actually a private endpoint going in here, or a private link, I would rather say, then you actually can connect your, let's use the blue again to make it more, so there we go. Then you can connect your Application Insight like this. Then you can, on your App Insight, you can say that if queries are allowed outside, or if it's just ingestion that is allowed, or if both of them is required to do inside of your private endpoint network. So you can decide a bit like that. But that's really locking it down if you want to do that. A little bit, yeah, I think that's it. So in this case, as you can see, we have covered a bunch of stuff, and we got a small little map on this part. And hopefully you gain a bunch of understanding about the network routing and where to go. And as I said, a lot of the troubles that I get when setting things up, like an APM or a new Logic App standard, a new loading landing zone, it's a lot around DNS, it's a lot around firewall rules, and it's about understanding where things go. So keep in mind where your traffic is going, how is the traffic going. Like I said, if our Logic Apps need something, it's going to go up through the firewall, going to the private resolver, and either to our private DNS or up to the Azure DNS, depending on where your record is stored. And also, make sure to understand the difference between a service endpoint and a private endpoint. Service endpoint has been there for a while. It's nice. As I said, you can open your IP for your development, so forth. But there's also things like you need to be able to have you have your exposure, and maybe you don't want that. Maybe doesn't really matter for you, but it's important to know. I think my time went off. That was the alarm. Let's go going there. And I think I've done everything. And if you have any questions, just let me know. Just poke me outside. And besides that, I just want to say thank you very much. And I hope you enjoyed my session. And then you see my contacts there. So just reach out if you have any questions or you want to talk integration with networking or integration in all. And have a nice day. Cheers. Bye.